Questions about your homework?
Can we do one?
Give me one. Four. Alright guys, I'm on number 4 from your homework. Is that you? Thank you. Alright, so this is the find formulas for f plus g, f minus g, and f times g, and then to give the domain of each. So before we can find combined domains, we need to find individual domains. So what is the domain of the square root of x plus 5? Carter. What's the domain of square root of x plus 5?
Square root of x plus 5. No, it's 5 to infinity.
Negative 5.
See, everyone's taking my. What are you writing on? What are you writing on?
Oh.
What problem is this?
Okay, this is number 4, but all I'm not even answering the problem right now. Right now, I'm just doing the domain of the individuals. What is the domain of an absolute value function? Shifted to the right 3. To the left 3. It's still negative infinity to infinity. Okay? The range is what's impacted there. Remember, that's a V that opens up. You should know those because those are your most known parent functions, right? So you should know, at least you should know what shape these are going to be in. So now whenever I combine, what is my combined working domain that I'm going to use as I start doing operations here? Negative 5 to infinity. Yes?
Yep.
So now, f plus g of x is just square root of x plus 5 plus x plus 3 with domain f minus g of x with domain and what else did it say? Multiply square root of x plus 5 times the absolute value of x plus 3. Domain? Negative 5 to infinity. That's it. That easy. Yeah. The only time it's going to change is if you do a division problem, and then you'd have to leave the bottom equal to 0 out of the domain. But if you divide them, if I did f divided by g, I'd have to leave out any place at the bottom would equal 0 from my combined domain.
Did you do number 8?
Yes. Number 8. Same deal, but this time I'm doing division. So f of x is x cubed. G of x is the cubed root of 1 minus x cubed. So let's find our combined domain first. What's the domain of x cubed? Negative infinity to infinity. That just looks like this.
It's like the N.
Yeah. How about cubed root? What's the domain? That's right. Negative infinity to infinity.
I don't even
So-
know what it looks like.
That's the one that looks like, it's this one on its side. You should know what it looks like that. That's one of your must-know functions, isn't it?
But it's like a 3D. Yeah,
Is
it's
it
like
not?
a 3D figure. What?
What?
On me.
What's the combined domain? Negative infinity to infinity. All right, let's do what it asked me. It asked me for f divided by g, and then g divided by x. So this one, x cubed over the cubed root of 1 minus x cubed. So for this one, shut up, Carter. I stay with this domain, but I also have to leave out any place that this equals 0. So solve it. Cube both sides. Subtract 1 or add x cubed. What does x equal? 1. But really, that's not what x equals. That's what I don't want x to equal, right? So I need to leave that out of the domain. So what is my domain going to look like if I started with negative infinity to infinity and I left out 1?
Negative 38 to negative 1 or 0.
That's exactly right.
Yeah, that makes sense. So I think I mixed that one with the of and of.
Oh, yeah, with the composition.
So you only have
So
to do the bottom?
I start with the combined domain, and then I leave out any place where the bottom equals 0.
But then if it asks, do you do that
Every time if you're dividing, yep. I'll show you. Composition is plugging one function into another function. So the second part asked me to do g over f. So it was g over f of x, which is cubed root of 1 minus x cubed. So again, my working domain is that negative infinity to infinity, right? That's what I'm working with to start with. That's a combined domain. But now I need to look, because out of that combined domain, I need to leave out any place where the bottom is going to be 0.
And you only do that for division?
Only division, that's it. So, is there any place where the bottom's 0?
Oh, x.
Well, x cubed, what could I plug in for x to make that true?
1, 0.
Right? So in this case, x can't be 0, so what's my domain here?
Wait, you want it to be 0?
Cannot be 0. Because whenever I solve this, the value it gives me is the value it can't be. Just like here.
What? 0.
No, I said it can't be 0. Yeah, it can't be 0. That's why I'm moving.
That's right.
Well, why do you do
How do
0?
you leave just one number out in interval notation? Back parentheses. Y'all tracking with me now?
I have to do the composition.
Okay, well give me one. 16. F of x equals x squared minus 1, and g of x equals 1 over x minus 1. And it asks me to find f of g of x and g of f of x and to state the domain. Well, let's do a little working domain here first. What is the domain of f of x?
1 infinity.
It's a quadratic. There's no radicals. There are no fractions. It's just negative infinity to infinity. How about g of x? It is. So what's the domain? What can x not equal? It can't be 1. That's the only thing it can't be, right? How do I say that? That's exactly right. That leaves out just 1. Y'all following me now? So what's the combined domain?
The one on the right.
The one on the right. That's exactly right. Negative infinity to 1. And as long as I don't do any division, that's going to be my domain for my function operations. Okay? By the way, what's the parent graph here? The reciprocal function. That's exactly right. Some of y'all said it's the one that does that. That's why it's got the 2 asymptotes at 0. This one's just shifted to the right one. Y'all with me? That parent function. Okay. All right, let's compose. F of g of x. Let's go back to algebra 2. F of this is what I'm putting in for every x in F.
Right.
Okay? So, x is x squared minus 1, or F is x squared minus 1, right? Instead of x, it's going to be 1 over x minus 1 squared. So 1 over x minus 1 squared minus 1.
I just don't know, like, that's what I got, but then I found mine.
Sure.
So it's supposed to come out the same combined domain.
The domain, yep. Because I didn't divide by anything. I don't have any new quotients that would impact my domain. What if I go the other, and you could simplify this some if you wanted. If you did this,
But how do you solve that now?
or it's not a solving kind of problem, it's just a simplified problem.
But you have to find a domain that
I already found the domain.
But it's still the same.
It's still the same. It's still the same. It's the combined domain. G of f of x, so this time I'm plugging x squared minus 1 into g. Remember, g is 1 over x minus 1. So this is going to be 1 over, not x, but I'm going to replace it with x squared minus 1 minus 1. Now this one's easy to simplify a little bit. 1 over x squared minus 2.
So you're filling it in with like the other x?
That's exactly what you're doing. You're taking everything that f equals and you're replacing all the x's in the other one with that.
Wait, so why is it
You do that again.
negative? Is it negative x squared or you distribute?
Well, because there's no exponent here. Okay. Now, this domain's a little bit different. Why?
Because it's minus 2.
It's x squared minus 2 in the bottom. So I got to leave out. Remember, if I ever do any type of division and I have a new quotient, I have to leave that out as well. So I'm working with this one. So right now here's what my domain looks like. But what I also need to do now is say, okay, what about when this denominator equals 0? Right? So now I got to leave out 2 more values from my domain. I also have to leave out the square root of 2 and negative square root of 2.
This is going to be a long one.
Right? Am I confused? So now my new domain for g of f of x is different than the domain for f of g of x, right?
But
It's
how?
because look at my denominator here. Whatever's in the bottom, I also have to leave out if it makes it 0.
But I thought yesterday you said that they have to all.
This is a 5-part domain.
Not compositions, no. This is a 5-part? No, this is not 5-part.
4 or whatever it is. It is 5. Oh, for 4.
Because when we composed them, we ended up with a different denominator than what we started with. So you still can't have the bottom equal to 0.
But you can keep that, right?
So we're dividing by something different than what we were. Yeah, absolutely. Absolutely.
But it's like it included like negative.
Thank you,
was
Noah.
the radical and included negative 2, negative 2,
If it included what?
negative, if it included negative also. Like if it was like already like if x squared minus 2 was under the radical and solve that.
Yes.
Would it be like negative 1 and be 1,
Where are you getting the 1 from?
2? The one that's already there.
Oh, because it was already there. Yes. Yes. I'm sorry. Yes.
Okay.
Yes.
They would stop at 2 when it goes.
Right.
You do 21.
Yes. 21.
I didn't eat my lunch though.
F of x equals 1 over 2x. G of x equals 1 over 3x. Both of these actually have the same domain. What's the domain? No. Thank you. Negative infinity to 0, 0 to infinity. The bottom can't be 0, right? Same thing here. This one has the same domain, which means since they both have the same domain, their combined domain is each one. Right. That.
So just to find a domain for those, just set those equal to 0.
Remember, as we look at domains, we're looking for where denominators equal 0, and we're looking for vertical asymptotes.
So you don't have to like the little.
Not vertical, I'm sorry, radicals. Bottoms to 0, radicals.
Yeah.
That's what you're looking for. Say again.
You don't have to plug it in.
Okay, so I'm fixing to. Alright, so now I have to do f of g of x and g of f of x. F of g of x, g of f of x. Alright, so the first one I'm taking this and I'm replacing the x, and then the second one I'll take this and replace the x here.
Isn't it the same?
No. Alright, f of g of x. F of 1 over 3x. Is it 1 over 3x or 1 over 3? It's 1 over 3x, okay. So 1 over 2 times 1 over 3x.
Oh, shoot.
Here's where it starts getting a little more complicated. This is 1 over 2 over 3x. So instead of dividing by a fraction, I'm going to multiply by the reciprocal. So this just becomes 3x over 2.
How did you do that? How did you do that?
This is 1 times, and then flip this over. 3x over 2.
Wait, so you don't have to like multiply the fraction with 2 times 1 and 2?
Well, this is 2 over 1, so it's top times top and bottom times bottom.
And the other one's just the
Yes or no?
And so
My domain, because there's no x in the denominator, then my domain remains the same. Negative infinity to 0, 0 to infinity.
I'm happy to know that.
That's my combined domain. There's no other denominator to check. There's nothing that I can plug in for x that's going to make 2 become 0. Let's go the other way with it. So g of f of x, so g of 1 over 2x. So 1 over, remember this was 3x. Same thing, top times top and bottom times bottom while I'm in the bottom, and flip it over. Again, there is nothing that I could plug in for x that's going to force the bottom to be 0, so my domain is still that combined domain. Noah's on fire. Yeah.
it's like only just one problem.
Yeah, I'm taking it back now.
I'm still over. Yeah.
Which part of the composition?
I'm kind of confused on like setting it up. Yeah.
So whatever's in parentheses is what's replacing the variable. Every single time. It doesn't matter what's there. If I said, what is g of Carter? It would be 1/3 times
So whatever is in
Carter. Whatever's in parentheses is replacing the variable. Or, well, you're plugging it in for x. So in this case, since it was g of f of x, I said, well, I know that f of x is 1/2x.
So you put, okay.
So everywhere in g, there was an x.
But why is there parentheses around the f and the x? Like there's two sets of parentheses.
Oh, that's where you have to put the X.
Yeah. This inside here is what's being plugged in for the x and g,
Okay.
but it's this whole f of x.
Carter, shut up. How do you know when it's like a switch domain?
So it's going to be the combined domain, but always check for any additional places where the bottom is 0. Like, is there anything that you could plug in for x that would cause 3 to be 0? No, because 3 is 3. It's never going to be 0. Now, if this had been 2/3x, I would go, well, wait. Can 3x ever be 0? Yeah, I could. If, in fact, x was 0, that would make the bottom 0. So I'd have to leave 0 out of the domain. So you're just looking to see, once you work with it, did it create anything new in the bottom of the fraction that you need to leave out? Like
If you don't
this one.
divide it, then it's the same combined domain as you started with.
As far as multiplication, addition, subtraction, multiplication, yes. Composition gets a little bit stickier, and sometimes you end up with some extra stuff in fraction denominators. This is composition. When you put one function into another, that's composition. FGX, yes.
Then what is the box though?
Same thing. It's just another way to write it. You could write f of g of x as f of g of x. It's just another way to write it. Another notation. What else?
Can you do one of the ones that's like the times 3 and the times negative?
Yeah. Which one? So 14 asked me to find f of g of 3 and then g of f. So this has nothing to do, in fact, these are just straight algebra 2 problems. This has nothing to do with domain or anything of the sort. F of x here is x over x plus 1. G of x is 9 minus x squared. So f of g of x we'll do first, or f of g of 3 we'll do first. So my first question is, what is g of 3? How do I find g of 3? Yeah. G of 3 is 9 minus 3 squared, right? Which is 0. So that means I can go, well, wait, that's not g of 3, it's really 0. So what's f of 0? 0. So f of g of 3 is 0.
So this one you don't have to find this domain.
You work, this is the one where you work inside out. Furthest inside first and then work to the outside.
So
Thank you for that,
put
Noah.
So you put 3 in for G tech, and you put G.
You put that answer in for f's x.
So G.
That's not composition.
It is composition, but with a number, it's a little bit easier to do because you can simplify them before you plug them into each other. I can't believe y'all don't remember this from algebra 2.
I do.
If I do g of f of 3, is that what I said? I brought them of 3. Then first thing I'm going to do is f of 3. right? Oh, sorry. That's the very first thing I'm going to do. I'm going to plug that in to f's x. So -2 over -2 plus 1. And I get 2. Do we all agree? So now I go, well, wait, I'm really not finding g of f of -2. I'm finding g of 2. Because f of -2 is 2. So I just replace it with 2.
So for the
Go ahead.
I don't know.
So it's 5. So g of f of 2 is 5. Or g of f of -2, sorry, is 5. Does that make sense? I think y'all are making this a lot harder than it is. Any other questions? Before we start math equations, or when you've looked at T-charts, when you've looked at relations algebraically, graphically, tabularly, everything we've done has been x, y, right? Those have been my 2 variables.
Is this the 1.1?
Yeah. Well, sometimes, 1.5. Sometimes we throw another factor into the mix, okay? And we call this a parameter. Have y'all heard of the word parameter before? Something that influences, something that or restricts sometimes. So a parametric function or a parametric relation is a function whose variables, so we got these variables x and y, but we subject them to a third variable. That we call t. So we're going to talk about this on the calculator, we're going to talk about it algebraically, we're going to talk about it in a table, we're going to talk about it lots of different ways. The easiest way to understand parametric functions is just to do one. And when you see it, you'll go, oh, that's really not that bad. Yep.
Yeah, I definitely broke my phone.
They said, wait a minute, they weren't ready. Copying it down. Alright, let me show you what it looks like first. We'll do an easy one to start with, and then I'll do a harder one like y'all said. Let me do a little bit harder. Let's say I told you that x equals t minus 2 and y equals t squared. This is a parametric function. I've defined it with both x and y, but I have restricted x and y with another variable t. Okay? So this is what it'll look like. You'll have two equations, one for x and one for y, instead of just y equals something x. Okay? What does this look like in table form? Well, instead of x, y, I'm going to have t, and then I'm gonna call this x of t. So if I plug t's value in for the x equation, what do I get? And then y of t, and this should give me a nice ordered pair that I can graph. some values here, just so that we can pick up. Think about whenever you first started graphing things in whatever grade you start graphing things in, and you did a basic t-chart, maybe -3 up to 3 or something of the sort. We're going to do the same thing with this parametric function and see what happens and see what it looks like. Thank you, Hunter. Thank you. I might just stop with parametrics today and leave inverses for tomorrow. We'll see.
Yeah.
Do that.
We'll see. No promise. Alright, so tell me, if t is -3, what is the value of x? How did you get that?
From T.
You're just plugging it into this x equation, right? Alright, so -5. How about if you plug in -2?
Oh, it's sorry.
How about -1? How about 0?
-2.
1. You picked up the pattern now? It's just a little linear equation, nothing hard. Is anybody confused about where I got the purple numbers?
Oh yeah.
Where, Connor? Okay. Alright, let's do y then. If t is -3, what's the value of y? 9. How about -2? How about -1? 0?
4.
So let's put these points together. -5, 9. -4, 4. -3, 1. -2, 0. -1, 1. 0, 4. And 1, 9. Does that confuse anybody? I want you to plot these and see what it looks like. So just do a quick little graph. See what it looks like when you graph one.
Let me grab it.
It's like a backward check mark.
A backwards check mark.
So when you graph it, you do the list.
Not on your calculator, I'm sorry, I was doing something else. No, you like by hand, I'm sorry. I thought y'all meant. No, just sketch it. Just sketch real quick.
It's a V.
-5 up to 9. It's a V. Is everybody okay? Alright, let's keep going then. Let's talk about how we write the equation of this. This is, to me, the hardest part. So remember, I got these two equations, one for x and one for y, right? Think about this kind of like a system of equations, okay? We want to write just one equation all together with just two variables so that I can graph it instead of 3. Okay? So what I can do I'm going to solve the x equation for t. Y'all like steps. Here's step 1. So in this case, what would t equal?
2 and
X plus 2. What? If I add 2 to both sides, right. Or is everybody with me? Solve your, or not solve, sorry, substitute. Sub your new t equation in your y equation. So y equals t squared, right? Y equals t squared, but instead of t, I'm going to replace it with x plus 2. Think back to what, I'm going to leave this like this. You can FOIL that out if you want to. X squared plus 4x plus 4. But right now, it's in vertex form. This is a parabola with a vertex of what? -2, 0. Or it's the parent graph slid left 2. Look what happened when you graphed those two. Is that what that looked like? It sure is. Isn't that cool? That's parametric functions.
wait, how do you get this? In the circle?
Which circle? This circle? So I solved the x equation for t. So I got t equals x plus 2, and then I plugged that in for the t here. This was obviously an easy one, and we're going to do one just a little bit harder in just a second. Your calculator will graph in parametrics, but whenever you get into the squares and stuff, it gets a little bit harder. If you take out your calculator and you hit mode, everybody see mode? Go down to the 1, 2, 3, 4th line where it says function, parametric, polar. See what I'm talking about? Highlight PAR for parametric. Second, quit, so you come out of there, or just hit Y equals. Okay, so mode, and highlight PAR. And then if you hit your Y equals, you've got a place to put X and Y. And if you hit the variable button when you're in here, look at what variable pops up. It's not X anymore. Now it's T.
Wait, I don't see
Okay, let me show you. Let me hook the camera up. Mode. Here's parametric. Hit y equals. And now you have a place for x and a place for y. And if you hit the variable button that you usually use for x, it becomes t. So you can input your two equations there. Go into second graph. Oh, I don't know why my other rows aren't there. I don't know. Oh, because I don't have an equation in there. But once you type these in, you can have your table too. This is your x and your y, and this is the t that you put in. This is the chart we just did, right? Well, I didn't put the equations in exactly. What are they? What are the equations? One was t what? And x and t squared. Three what? Huh? Go second window and make sure that says ask right there. No, the first one says ask, the second says auto. And now second graph, and you should be able to input any value and hit enter, and it gives you the x and the y. Yeah, you have to type them. Yeah, whatever numbers you want. So I did -3, enter. -2, enter. If I want to do 10, enter. Huh? It does, but then you can't go in between if you want certain values. That's why I like ask. But yeah. Hit y equals. Silly Noah. One more together. I'm saving inverses for tomorrow because. Yes. exact. I mean, you can do decimals. Undefined. Alright, does your chart look like this? You won't. You won't have that point. Write an equation for the relationship. Write an algebraic equation for the relationship. You do the equation. Huh? We will graph it in just a minute. To graph the relationship. And I'll show you in just a second how this relates. I did, but I think Teague used them all. What do you mean? Well, so what I did was I just squared both sides here, and it went away there. We're not going to delve too deep into parametrics because even in calculus AB, we don't focus on parametrics. It's a BC topic. The most I want you to be able to do is what we've done here and recognize them, but past that, we won't do anything else more with it. Okay. I want to show you how to do it on the table on your calculator. I want to show you how to plug it in. I want to show you how to come up with the equation, but past that, that's all you need to know. Okay? Is everybody okay? I kind of worked that out while y'all were working it out. Do y'all have any questions? I just put a smiley face because that's my y-intercept, and that's what it shows there. So right away I recognized that that was. It gets into the domain restrictions of it that we're not going to get into with this. Not with the graph on it. But you let it help you with your tables because it will help with that. Other questions? This is a pretty easy Wednesday lesson. delve a lot deeper with inverses than what we did in Algebra 2. So, I'm going to leave it there for today. For homework, you're only going to have 8 problems, and 4 of those problems are just finding one value. And let me show you what I'm talking about. Oh, so, yeah.